Hello and good morning, everyone. Welcome back to another YouTube video. So this is the fourth devlog, I believe, on the channel for Slither Wars. It's been about a week since I actually recorded a video, and it's been a really busy week, really eventful week, and also an amazing thing happened. So I have landed my first internship as a junior in college, and that's great. So it's been a really busy week, adjusting, uh, applying, and yeah, I'm really excited to start. I'll give you guys more information on that throughout the weeks. But yeah, today we're going to be checking out the latest improvements to the game that I made. And kind of just running through the code for you guys, and yeah, let's get started. So here's the code base, of course, still the beautiful Rust language. One of the main things I did right off the bat was refactor the code. Um, I watched a few videos on how other people structured their Bevy code, and I sort of like this component system and module type architecture that they're using. And so basically, as you guys can see in the file explorer, here, I'll make my VS Code a little bigger for you guys. Um, so yeah, we have the main, which is obviously the start of our module. Then we have resources, systems, components, and these are basically global. So everything inside of here, right? All of these components here should be used by more than one module. So if it's being used by more than one module, then it should go in the global systems, because that makes sense, right? And so um, I did that as refactoring. Um, Also have, the utilities, resources for game state, the global systems, which I'll go through a bit in more detail later for you guys. And yeah, so also the bot, orb, and players, they each have the same sort of architecture. So it makes it pretty predictable and pretty easy to know, like, okay, where's the orb, the systems for the orbs? Well, it's just in the orb module and in the systems module, right? So, yeah, I thought that's just a clean way of doing things versus, having like a orb.rs file and then putting all the components and all the modules in there because it kind of clutters up the code, to be honest, in my opinion. And yeah, I wanted to make things more modular. So next thing I worked on is the collision system. So I'm gonna go ahead and actually play the game for you guys, and then I'll go through the code a little bit more. Um, so let me cargo run, and we can actually start up the game. And right now, you see I'm moving the snake around. It's growing in length. Oh, and I died. Oh my goodness. Well, you can see that when I die, I leave behind some orbs, and this other bot snake is continuously going and collecting orbs around the map. So that's pretty cool. Now, there are still obviously a few bugs that I have to fix and improvements, but this is more progress. I do have bots now in the game. As you can see, the bot can also, it also has pathfinding, so it actually targets and searches for different orbs to find on the map. Um, and it does have a bit of randomness also, so it has a 70% chance of targeting food and then a 30% chance of exploring random positions on the map. And this makes the food targeting more random instead of literally searching for the closest food item and just kind of being predictable. Okay, I'm not sure how it died when it's only player. That was weird. But yeah, instead of just literally going for every single closest orb, it kind of has that 30% randomness to change direction, which can make it target something else. And yeah, so again, obviously, way more improvements need to be made, but this is some progress that I made. So that's the latest example. And yeah, let's get into the collision system. So the collision system is actually inside of the global systems, right? And check snake collision. So the reason this is inside the global collision is because I've actually created a new component called the snake entity, right? So this snake, there's not OOP in Rust, but you can kind of think of it like snake, both the player and the bot both derive from the snake. So anything important to like the length, the growth, and the color, basically all the physics of a snake is separated from the player. Before I had both the player and the bot implementing like these same values, and that didn't really make any sense because the player and the bot are just two different entities that have different logic, right? Like obviously the player is the user, so they need to be able to, control the input of the snake versus bots, they just need to move throughout the world. So makes more sense to have a unified logic for the snake. Um, so yeah, we have the snake here. And again, it kind of just, collects its own segments. We also have, segments like before, segment position history. And then we have the snake segment component. And this actually tracks the owner. And this is very important because one of the bugs I ran into while developing as well is the bots, when they ate food, only the player entity would grow. And that's because there was no way to tell who was the owner of this segment. So I had to add this code right here. So every time a snake grows in length, um, the segments keep track of who this belongs to. And this makes sure that as people eat orbs or kill, um, we can, add or subtract to the correct owner. And obviously, we can also track the dead snakes and the killer entity, right? So yeah, let me go back to the systems. So basically, how this works is we grab these segments because we want to check the collision on segments, not the snake, head, obviously. Um, and then we also keep a hash set map, basically, of the process deaths because Bevy can like process like multiple iterations of this collision system per frame. It happens like faster, like microseconds, milliseconds, right? And so we just want to make sure that we're not, obviously trying to kill the same entity twice because it's already been processed. So that's what this map is. This only exists when this function call exists. So this will never really, take up a lot of memory. Um, and yeah, if the segment owner already has been processed, then we just, skip this for loop, right? And we just query some of the components we need for the logic, and the main magic happens in this collision function. Now, Levy doesn't have its own like built-in collision system, so I kind of just wrote my own logic. It's just this function literally to check, if two vector twos have overlapped, some boring math stuff, and if so, it just returns a sum value, and if not, it just returns none, right? And yeah, basically, we check the option and we grab the snake and we grab the position, and this position will be used later. Um, right now, as you probably saw in the demo, when the snake dies, the orbs just kind of like circle each other. That's a bit weird. But I just wanted a working demo. Um, but in the future, I want to use this depth position of the snake to sort of, like in the real game, lay out all the orbs and wherever the snake body was before contact with an enemy. Um, so then we obviously we despawn the snake and then we spawn the death orbs right here. And all this does is just loop over the snake's length. It cuts it in half, um, and then it spawns all the orbs, right? There was also another funny bug where I accidentally had two orb components. Um, because GPT had like obviously I use GPT for this project. Like I said before, I'm not a game developer. I'm just doing this for fun. So AI helps me to iterate faster. Um, but it generated another orb component, and I didn't realize that. And so some of the orbs were able to be eaten, and some weren't. And I was confused. I'm like, code doesn't look bad. What's wrong with the code? And then I finally realized that it was using two different entities. I mean, it's two different components, even though they were named the same thing. Um, and so yeah, that was a bit funny. But yeah, that's basically how the collision system works. It's pretty simple. And again, because both the player and the snake, um, I mean, sorry, both the player and the bot both use the snake component, we can write the same logic for both of them. And the easiest way to check, who is who is, the segments know who their owner is. So it's really great. It's pretty good system. And next, I guess I can show you guys the bot players, right? So here's the bot plugin system. Basically, the two main things bots need to do is move around and eat. I'll probably add some kind of uh some kind of collision avoiding system to the bot later. Where like, because right now, the bots will just run into each other and they won't even try to avoid each other, which I would prefer not to have. Um, so I'll probably add that in the future. But here's the bot component. Pretty simple. Basically, we just need the color, the target position, and decision timer just to control like, you know, what it wants to do inside the world. Um, And inside the systems, spawning a bot is pretty similar. We just, grab all our global constants and we create a bot entity. Um, and yeah, we kind of just, spawn the segments. This time though, a little bit different. We're actually we're pushing the segments into the snake um segments queue, right? And then we're actually querying the bot entity and adding them directly. So this is something that we didn't do before. Um, and so, obviously, because we're having multiple players that can grow versus just a player, this makes more sense, right? And yeah, so and then also the movement, bot movement, um, pretty simple, really. Uh, we're just grabbing the orbs, right? So we're querying the orbs. So you can see, where is it? Yeah, in this third part, we're grabbing all the orbs in the game, and we're trying to check which orb is closest to the bot, right? And then obviously we're doing a little magic here with the distance and checking if the timer is so that the bot doesn't like speed around the map and just try to eat everything as fast as possible. It kind of makes it a little more realistic because realistically a player is not gonna go after every single orb. They're going to, make a decision and go, based on who they want to play the game, right? So, um, yeah, this is just some, tracking logic, trying to find the closest orb depending on the current player's, vector two position. And then if the target is found, um, we basically add the segment to the bot, right? So we can see bot movements dot push, and then we push all that data. And And then just for the movement logic, like actually, showing the animation of movement, we have to update all the segments every frame, so they move forward after the head of the bot. And that's kind of what that logic does. And then for eating, pretty much the same as the player. We just get the distance of the food. And if we come in contact, then we add a segment to the bot. And yeah, and we do that by using the position. It's pretty cool. We basically get the latest position of the bot and we add the segment right behind it, which makes it look like it's grown. And we also, as you can see, we're now passing in the owner entity to more functions this time. And also, we can see right here that we mutate the snake segments, not the actual bot segments, because each snake has individual data, right? And bots obviously have their own ad segment code as well. So yeah, and I think that's pretty much most of the changes I did. I think there was one other thing that I did in the player, which I can kind of show you guys real quick. Um, where is it? Where is it? Where is it? I forgot where it is. Let me see. Let me yeah, let me search this. Oh, okay, it was right here. Yeah, so basically this right here, I'm not sure if I talked about this last time, but basically the player is allowed to get bigger in width and obviously radius as they eat food. So I can show you guys a little example of this really quick. If I go if I go into my constants and I change, let's see, where is it? Um Orb spawn per player. So right now, 100 orbs are spawned in the game per player. I probably also have to update this to like spawn for the bots as well. Um, yeah, let me change this to like 1,000, right? And then if I run this code, yeah. So if I run this code, you can see a spawn. Now I'm just doing this so that it's easy for me to show you guys the snake growth, right? Um, okay, yeah, we killed them. That's good. And as you guys can see, hopefully the snake is actually getting like bigger um in size, right? And so this is kind of what I want. So every 250 points, the snake grows a little bit in radius. I think it's like 1.5 or 2.5 or something. Now as you guys can see, it does look weird because the new segments of the snake are bigger than the old ones, which is why the snake just body looks really, really weird. Obviously, I'm gonna change this in the future. This is another bug. Um, but yeah, I just wanted to show you guys. It does look pretty cool though, to be honest. And yeah, obviously our score is 1,000, and you can see our circle for our snake body is slowly getting bigger. And this actually looks pretty crazy. But I can keep eating stuff. I mean, I'm pretty much filling up the whole map at this point. There's also a weird thing where like when the snake boosts, it's really, really longer than it actually should be. I'm still trying to figure out a way to fix that. But yeah, I hope you guys did enjoy this video. It's a little long, 15 minutes, but I just want to go over the changes I've made in the code so far. And yeah, I'll catch you guys in the next devlog. Thank you for watching and subscribe for more. Peace.